Okay, continue with our one example of one free variable. From the last video, we'll talk about a solution set of a homogeneous system, like that. Okay, so we'll come to the point. So in that one, the entire solution set can be expressed by a scalar times a base vector, 4/3, 0, and 1. Continue with that. So the equation of the form u equal to su plus tv, this is in Rn, it's called a parametric vector equations. All right. Again, this is in Rn, in R. Sorry, not Rn, R. Just real number. Number. All right. So in our example, we only have 1, right, as our base. So x equal to any constant times the vector t. It's a parametric vector equations. It's called a parametric vector. Parametric is referring to this parameter t right here. So whenever a solution set is described explicitly with a vector as example 1, we see the solution is in parametric vector form. So now we're going to come to the solution of non-homogeneous system. What is non-homogeneous system? All right, meaning this right-hand side right here is not 0. All right, so the b right here is not a 0 factor. Therefore, it's called non-homogeneous system. All right, we had the same vector as the previous one. So like the one before, you see that? We had the same matrix. So the only difference now, right now, is the right-hand side is different. It's non-zero. Well, we'll do the row reduced echelon form. It'll be the same. So that will be give you 0 and 1 right here. Be the same. The only difference will be the right-hand side is non-zero right there. Okay. So if you write it down in terms of in terms of each variable, so x1 equals to 4/3, x3 equals to -1, x2 equals to 2, and x3 is free variable. Okay, x3 is free because it has a 0 row there. So we continue on, and we write down this in the solution set in the vector form. X equal to x1, x2, x3. So here we can separate them. Okay, what we want to do is separate the term with the x3 and without the x3. So that becomes like this. Then we factor out the x3. You notice that this v is the same as homogeneous system. Right? If I roll back, you recall there's a 4/3, 0, and 1. So we'll come back here. It's also 4/3, 0, and 1. Okay? So there's a P. This P is called a particular solutions. If you plug this P in the place of x1, x2, x3 in the system, it will be a solutions. All right? However, this V right here, it will be 0 anyway, so it is not going to affect anything. All right? So the equation x equal to P, the particular solution, plus x3 times V homogeneous solution, writing T as a general parameter, so x equal to P plus TV. So that's a solution to the non-homogeneous. So this is a solution to the non-homogeneous system. And describe the solution set in a parametric equation form right here. Okay? And that's in R, sorry. That's in R. All right? So the solution set of Ax equal to 0 has a parametric vector of this guy. So you think about that. If I plug it in, right? So this is meaning solution A P equals to B. That's a positive solution. So if I apply this, A times P plus X3 plus V, remember V is a solution to the homogeneous. That means AP plus X3 V. I'm sorry, don't forget A. You distribute the property, right? AX. Remember, AV, my bad. AV. Remember, this is a solution to the homogeneous, meaning this guy equal to 0 vector. So that becomes AP. Well, AP equals to what? We're here equal to B. So that satisfies the original vector equations. Okay. So vector P itself is just one particular solution of this guy. All right. And then all the rest of it coming from the form of X times what? P. That should be multiplication right here, sorry. All right, the rest of it will come from this any X times the rest come from any combination of P plus X3 times V. So this can create very many solutions here. So now we're going to describe the solution AX equal to B geometrically. What does that really mean? Okay, what kind of impact does B non-zero here factor we can have? All right, so if we have V and P in R, or R for the effect of adding P to V, what does that really mean? Okay, adding P to the V or X times V, what does that really mean? Well, think about that. So if you have a V here, P, so this is what? X plus P. So what happened is the line equation you had before added a P simply lifted the line. So added a P, the only thing different is the original line equations, you added a P, either you lifted the line up or a different B, well, you might lower the line. So the impact on AX so this right here is non-zero, okay? This non-zero have impact just simply moving the line up or down. That's it, okay? So the solution set of AX equal to B is a line through P parallel to the solution of what? Of the homogeneous solutions. All right, so that's what it is.